roll up the tasks and get your top level estimates. So let's look at what are the estimation techniques that are available. There are multiple estimation techniques that are used by different projects in different organizations. Some of the common that are listed over here, and we'll try to go through some of these estimation techniques. There are pure expert judgment and historical data. We have wideband Delphi, source line of code, function point, use case point, story point, Monte Carlo, COCOMO model, test case point, or function test points. So these are the various tools and techniques, and in reality you would see many other techniques are also used for deriving the estimates. So we'll go through some of these techniques by now. So the first one is pure expert judgment. So in this case, a person who might be a technical lead or a project manager or a subject matter expert, he would go through the requirements, he will try to understand the requirement, and he will come up with his guesstimate. So the person will say, okay, I have worked on this particular login module earlier, and based on my experience, the same login module developed for this particular project will take 1 month. So this is based on the feedback of the expert. And you might see practically that this kind of thing is, this may not have a statistical confirmation, but this is very widely used. You know, we ask the experts for the estimate, and whatever number is provided by them, that is the number that gets quoted as an estimate. So this is one technique used, which is just pure based on the expert opinion. The next technique is using historical data. So most of the organizations would have the project historical data available with them. So the projects that we have delivered earlier, we would know how much cost was involved for those particular projects, how much resources were working on those projects, and how much was the duration of that project, and in which domain or what kind of work that we did in that kind of project. So we can use that information. We can try to have an analogy with the new project that we are working on or that we are trying to estimate. And if we see an analogy with the existing projects, then based on that we will try to extrapolate and get the data, which we can project as an estimate for this particular project. So estimation by analogy is a very common scenario where we try to see if the same or similar domain application project has been done by us and use that data and refer that for the estimating the current project. The next similar method is proxy-based estimating, which is based on an idea that if the person is developing a component which is very similar to the one that he has developed previously, then it will take approximately the same effort that it took in the past. So what we are trying to see is, okay, how much work was required for the similar work in the past, and as a matter of guesstimate, we can say, okay, it will take approximately the same duration. So it's based on a formula or a linear regression that is used to calculate the estimate for each task from the history. The next method is a wideband Delphi method. So this particular process is a very repeatable process. It's an estimation process which have multiple rounds of iterations, and it tries to get a consensus. It tries to arrive at a data point which we can use for estimations. The way this particular process works is, we start with round 1 and we ask all the team members to read the requirement specification and come up with their estimates, and then all of them share their estimates. As you can see in the bottom graph at the bottommost line, round 1, the estimates might vary to a significant range. You know, some of the team members say, okay, this is very easy task looks to me and can be done fairly quickly. Some of the other team members might say that this is very complex and this would require significant efforts to be done for that particular project. In that case, we ask the team members to share their views, to share their opinion, and then we ask, why do they think this is taking more time or less time, or what was the basis of their estimates. Now once we hear that, then the team members might know, okay, the team member who gave the higher estimate really has a valid point, and I also needs to consider that. I also need to factor in. And then the team again re-estimates. So then the range will reduce. And then in the similar manner, the team will arrive at either a number or at a range which is acceptable to everyone. So this is a wideband Delphi method where the team provides the feedback and collectively they try to arrive at a range which will be acceptable to entire team. The next method, which is again a very frequent method seen in software project estimations, is estimating the source line of code. So basically a unit to the line of code of a software program. How much line of code will be required to be written for this particular program. So in this case, we might have to divide the problem into modules and then sub-modules and even to a lower level until it reaches to a level where we can estimate it. We might have some kind of algorithms written or flowcharts written or a control flow of the project derived. And based on that, we try to understand how much of the line of code is going to get involved. We can also use the historical data, and we can also use the industry data, that if you are using a program or if you are writing an assembly language program, then for the single for loop statement, how much lines you will have to write in assembly. For a same statement, for a same logic, how much line of code will have to be written in C, C++, or Java, or any of the other languages. So what we are trying to do is identify how much line of code will have to be written for this particular project. There are two major types of SLOC, the software line of code. One is physical line of code, where we count each and every line of the source code, or it can be a logical line of code, wherein we identify the executable statements. That is, we do not factor in the comments, or we do not factor in the blank lines and things like that. So KLOC is one of the very common method that has been used historically for estimating the software project duration or software project estimates. The next is the function point based estimation. So function point based estimations are basically from the user's point of view. It is based on the function count and based on the user request and what the user receives in return. So what is that user is asking from the system, and what is that user is getting from the system. So it has 5 key components. It has external inputs, it has external outputs, and external inquiries that are coming to the system, and internal logical files that are used for the internal processing, and external interface files. So it factors in all of this data, and then it comes up with the function points. And you can have unfiltered function points, and then you can normalize this data, and then you can get more structured or filtered function points. So this is a very commonly used method in software project estimations. The next one is the use case point estimations. So this particular estimation method is based on use case modeling or UML modeling, wherein you create use cases for various scenarios, and then you estimate based on the various factors of those use cases. So how much is complex that use case is? Is it a medium complex, low complex, or a high complex use case? Are there any other factors that are involved with the use case? What is the technical complexity factor? What is the environment complexity factor? What is the unadjusted use case points that are involved in this particular use case? And what is the productivity factor in your organization or for that department or for that team? So we use all of this data, and then we try to come up with the use case points for a particular project. So we might have, let's say, 100 use cases, and then we'll try to categorize them, whether they are simple, average, or complex, and then apply a weight to them. And then based on that, we try to come up with the use case points for a particular project, and then estimate based on the use case points. The next method that is used in agile software development or agile programming is called as story points. So story point is a relative measure of complexity instead of an effort, or instead of an absolute number of hours. So what we are trying to give is a relative sizing of the project, and this is used in agile estimation and planning. So what we're trying to do is, if I start with the story 1, a user story 1. User story is a piece of functionality that I'm working on. I start with the user story 1, and I say that this is a medium complex user story. So I give it a story point of 3. Then I start with the next user story, and that is double complex of the story that I was previously reviewing. Then the story points will be twice as complex or twice the number as my previous user story. So this will have double the story points. So based on this analogy, we try to identify the story points for a project. There are similar analogies available related with that, which is t-shirt sizes, which means if a person that I'm looking at is actually having a t-shirt size of medium, a medium size t-shirt fits for him, then if I see a next person who is much thin than him, then what is the t-shirt size that he would require? If I'm looking at a person who is much fat, then what is the t-shirt size that he would require? So based on that, I try to arrive at a t-shirt size. Or similar analogy is for dog points. So if we start with a particular dog breed, and if we look at a compare with next dog breed, is it twice tall, lesser tall? Based on that, we arrive at dog points. We also use zoo points or ideal days are the other terminologies that can be seen. Ideal days is the number of days that the story would take, assuming that there is no other work that is involved. So we are not counting the time that we spend on non-project related activities, which might include anything from your emails or meetings or any of the other discussions which are not involved. And there are two processes that are used in the agile environment. One is the Scrum method, which calls it as a planning poker, and in extreme programming, the process is called as a planning game. So in planning poker, we get cards of different story points mentioned in that. All the team members work together and they understand the requirement, they clarify the requirement, and after that, all of them show their story point cards together. And the team reviews the range of those cards, and the people who are having the lowest or the highest story points, they will explain their rationale, and the team will again reevaluate based on the discussion that has just happened. So based on that, the team will try to arrive at a story point. In planning game, each story which is written on index cards is given to the estimator, and then estimators will have 1 or 2 or 3 weeks estimates added to that. And this particular process is repeated continuously throughout the project. So the major characteristics of story points are they are provided at the start of the project, but the agile nature of the project is in iterative, incremental, and that's how we keep on iterating the projects as well. The story points might get added or reduced, they might change. The another estimation technique is called as 3-point estimating or PERT technique. So which uses 3 separate values for estimation, and they are derived from optimistic, pessimistic, and most likely values. So we try to get someone's opinion. Okay, what is your opinion about having this project completed? What is it an optimistic estimation, or what will be the range? Or if I ask you, what is the most pessimistic number that will you give for completing this particular task or this particular story or a requirement? And then we get that data, and then we try to arrive at the statistical probability outcome and a weighted average. And then we come out with the estimate. So this is a technique that we can come out wherein we ensure that the over-optimistic or over-pessimistic estimations are factored in or are normalized in a logical manner. There are many other techniques also involved in the estimation process, and those techniques we'll just list or we'll go through some of them quickly. One is Monte Carlo technique, which is based on generation of multiple trials to determine the expected value. So we'll have multiple trials, and then we try to arrive at the values for the variable that we're discussing on. The next one is the Parkinson law, and this law says that work will anyway expand to fill the time available. So instead of estimation on absolute number of hours, we'll say that the cost will be determined by the available resources. So if the software has to be delivered in 12 months and 5 people are available, then we say it is 60 man-month project. The next one is test case point, where we try to identify the estimates of the testing projects using test case as an input. So we have use cases. Based on use cases, we derive the test cases, and we try to estimate the test case points, and we apply the normalization factors, and then we have the filtered test case points available for estimation. Another technique which is practically used is pricing to win, so which is cost estimation technique. So price or quote as per what the client is prepared to pay, whatever is the bid amount and whatever is the quotation amount. So based on that, we try to bid and get the project. There is a detailed, extensive cost estimation model, which is a COCOMO model, which is a hierarchy of software cost estimation models. It involves the basic COCOMO model, intermediate model, and detailed model. So it is trying to estimate the efforts and the development time based on the coefficients. And the coefficients and parameters are different in different models, and the details are included in the specific models. And based on this data and based on the line of code projections, we try to arrive at the cost estimations of the project. So we have so many estimation models, so much ways in which we can come up with estimates. So what are the estimation methods that we should be using? If you are estimating a new project, what method or what technique should you use? So there are some guidelines that are mentioned over here. So if your project requires some strategic decision making, you're not trying to do each and every minute requirement level commitment yet, but some ballpark number is required for strategic decision making, then you can use top-down techniques. If the cost and time is important, if it's critical and it's going to be measured against, then you should be using bottom-up estimations. If there is a high uncertainty of the project, then it's recommended that you use top-down estimates or guesstimates for those projects. If the project is internal or small, then having entire estimation cycle applied probably would be an overhead. So in that case, you can have top-down estimates. If it's a fixed price project, it's always recommended to have the bottom-up estimates. You go to the lowest level, you identify each and every task, you estimate the task and roll up at the higher level. If the customer wants all the details, then also you will have to go to the task level and provide the estimates based on the facts. So you're not talking based on just some expert's opinion or someone's feelings. You are talking with the base of data and with the basis of facts. If the scope is unstable, if the scope is changing very frequently, then it's recommended that we use top-down models. So these are some of the guidelines that we can use for identifying the estimation techniques. And practically what we do in the industries is we use a combination of multiple techniques so that more predictable estimates can be generated. Now we look at what is the estimation management cycle and how the estimates typically work. So what we do is we prepare estimates and we generate the estimate baseline, which is communicated to everyone. Then we apply actuals to it once we start working on the project. We get time entries, we get resource expenditures and all the details. And based on these when we apply actuals, we try to do a comparison of actual versus estimated. And we have project management systems, we have earned value management, and we have several other tools for that. Then if required, if the environment is changing, if the scope is changing, or the project environment is changing, then we re-estimate the project. And the cycle continues throughout the project. And then we have end of the project or end of the phase. Then we document the lessons learned and we discuss how we can improve the estimation process. One of the factors we need to make sure while we are doing the estimations is we need to have very strong matrices for tracking our estimations. We cannot have just estimations given and not tracked thereafter at all. We need to continuously make sure that whatever estimates we have given, either phase-wise, module-wise, or requirements or story-wise, we are tracking against them. We are making sure that our planned and actuals is matching. One of the tools that can be used for this particular tracking is earned value management, which is a project management technique which can be used for measuring planned versus actual. In agile environment, the burn down chart, the release burn down chart, or a project burn down chart or a sprint burn down chart is used to see if the project is on track or not. Are we going as per our plans or not? But this kind of metrics is definitely required to have in the projects. Now let's look at some of the challenges. What are the challenges that we deal with or that we face day in, day out in our estimation processes, specifically